Hello, in this video we're going to talk about 2.4 or dividing polynomials, the remainder and factor theorems. So from the previous sections we talked about polynomials. We are transitioning into how to figure out the zeros of a polynomial, and that's the main idea, that's the main goal from talking about polynomials. So right now we're going to talk about how to factor out a polynomial. So what are some techniques? For example, here we have the equation, okay? And this equation specifically describes the number of eggs inside a female moth. So it's kind of weird, but this equation describes that when the value of x is between 1.5 and 3.5. So those details really are kind of beside the point for us. So we're wondering, if the number of eggs is 200, then what would be the value of x, right? So we're looking at something like this where we say, well, if f of x is equals to 200, then what is the value of x? And hopefully, we can see what's going on. We are somewhat aware of what the algebra that needs to happen for this to, go on. So the first thing we would do is take away the 200 from both sides. Okay, and so we get that this polynomial now it's equal to 14x to the third power, and this is all that is left, right? So like we did in the previous video, or just in general, you would try to see what factors out from all of those terms. And so once we do that, we were able to then figure out the values of x, but it's kind of hard. If you're just aimlessly trying to figure out what would factor or what wouldn't, it's going to be very difficult. Okay, so it's not going to work in this specific scenario to try to factor this thing. Okay, so what do we do? Well, hopefully you remember doing long division of numbers, right? So for example, you have this expression, x squared plus 10x plus 21 is divided by x plus 3. Okay, so this is one way to represent it, as a fraction or as a rational expression, right? And here is the long division setup, right? Where the x plus 3 is the divisor, and as we can see it has two terms and it's a binomial, right? Now whatever is under the division symbol, it's called a dividend, and this thing has three terms and it's called a trinomial, right? So hopefully that's kind of obvious, and I always like to kind of take a step back like I wrote on there and just look at it in the perspective of numbers. For example, 42 over 7, it's very easy. It's something that you can relate to. That's a fraction. Or in the division symbol format, 7 goes into 42 how many times? So let's go ahead and do it. It's super easy. 7 times 6 is 42, and then you get 0 left over, right? So we know those different parts, and those are going to be the same parts that we're going to see in long division of polynomials, right? Something like this. Very, very similar. So let's go ahead and do an example, right? Whether you remember or whether you don't remember, let's try to do an example where we're going to divide x plus 3 into x squared plus 10x plus 21. So, what do we do? How do you do this? So the first thing that we want to do is to arrange the terms so that they are in descending powers of x, like power 2, power 1, and then no x. Power 1 and no x, right? So they have to be in that order. The dividend and the divisor have to be separately organized like that. Okay? So now you want to divide x squared, which is the first term in the dividend, by x, which is the first term in the divisor, right? Or you can think, what times x would give me x squared, right? However you think about this. So we're going to put the term above the x term, right? Because we're going to align them, right? And so we multiply x times this, right? So x squared plus 3x, right? So we multiply everything in x plus 3 by the x. Then we align the terms of the product under the terms of the dividend, right? Okay. And we are supposed to subtract. We subtract from above. Now here's where a lot of people make a mistake, right? This minus that's out here, right there, is going to be distributed into that x squared and that 3x, okay? So in other words, you're saying x squared minus x squared, right? So what is x squared minus x squared is 0. Then 10x minus positive 3x. So what is 10x minus 3x is going to be 7x. Okay? Then we bring down the next term, right? We bring down the 21 from the original dividend, and then we add algebraically. Okay? So now we're looking for something else to multiply by. Okay? You can say divide this 7x by that x, or you think, what number times x gives me 7x. Okay? So positive 7, and then we do the same thing, right? So 7 times x is 7x, and 7 times positive 3 is positive 21, and then we subtract. But remember, we are in one way distributing that minus sign into everything that is here inside of the parentheses, or just think we change the signs, right? So 7x minus 7x is 0, and then 21 minus 21 is 0. So therefore, the remainder is 0. Okay? So what we say now is that the quotient is x plus 7, right? Or the solution is x plus 7, right? So if you divide x squared plus 10x plus 21 by x plus 3. The solution will be x plus 7, right? So in other words, x squared plus 10x plus 21 divided by x plus 3 is going to be equal to x plus 7, right? So we have successfully performed a long division of this, and hopefully this is a good reminder as to how to do it, or a good explanation if you've never done it. Okay, so here's a quick, I guess, guide to performing long division. So the first thing that you want to do, or that we did on the previous example, is that we arrange the terms in the divisor and the dividend in descending order, right? So whatever the highest power is, all the way to the left, and then the next one over in descending order, right? The powers going down. The second thing that we want to do is divide the first term in the dividend by the first term in the divisor, right? Kind of like we did, or re-engineer the idea and say, what number times the first term in the divisor gives me what I have in the dividend, and so on. So the result of the first term of the quotient, right? That's what we got. Then we multiply every term in the divisor by the first term in the quotient. Step 4 will be to subtract, right? You subtract the product from the dividend, like we did. And step 5 is to bring down the next term in the original dividend, right? I mean, these are the very thorough steps that we just did, and right now it seems kind of hard to kind of wrap our heads around these different steps because they're very specific. But if you do a problem, you notice that when you get to here, you may have to keep doing, right? Step 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. If it's a very long polynomial that you're trying to divide, right? So you're going to have to do these steps as many times as needed until you're done dividing, right? Until you have nothing else to divide into until you reach your remainder. Okay? Now, let's do this division, right? This polynomial division, and kind of go over those steps that we just talked about, right? So obviously, everything that we talk about, we want to put into action, right? Otherwise, there would be no point of talking about it. So 3x minus 2 is my divisor, and that's already written in descending order, right? It's x to the power 1, and then next to the 2 there is an x to the power 0, which is just a 1, or we don't write it, right? Okay, so next thing, right, we're going to organize the dividend, which is 6x to the power 3 minus x squared minus 5x plus 4, right? That is in descending order: power 3, power 2, power 1, power 0. And at this point, I think we're ready to start, right? So here I'm going to do the division of the first term in the dividend by the divisor. So 6x to the third divided by 3x. So this x cancels. This becomes a power 2. 6 divided by 3 is just a 2. right? So you have 2x squared. So 2x squared is going to be the first thing that I am dividing by, right? So 2x squared times 3x becomes 6x to the third power, and then 2x squared times negative 2 becomes negative 4x squared, right? So first thing we did was divide to figure out what to multiply by, you know. If it's easy to eyeball it and just say, you know, what number times this give me this, then do it that way. And if not, do it this way, you know. First term in the dividend, first term in the divisor, right? So, okay, let's keep going. And then we're subtracting. 6x to the third power minus 6x to the third power is 0. Negative x squared minus negative 4x squared. So it's like a negative 1 plus 4, right? So that becomes 3x squared. And then we bring down this 5x, right? So now again, we say, well, what number do I multiply 3x by so that I get a 3x squared? So we'll do it here on the side, right? 3x squared, which is the first term in the dividend, and then 3x is the divisor. So the 3's and the 3's cancel. There's a power 1 here, so you can just say x to the power 2 minus 1, and that's x, right? So that is my next term, which is just an x right there. X times the divisor, so x times 3x, it's 3x squared minus 2x. And then I'm going to subtract. And 3x minus 3x is 0. Negative 5x minus negative 2x is the same thing as 5x plus, well, negative 5x plus 2x, which gives me negative 3x. And then the last thing to bring down is this positive 4, right? Now, the last thing to do, right, is divide the first term in the dividend by the first term in the divisor. So 3's cancel, the x cancel, and hopefully you're not tempted to say that we got 0, but to realize that there is that negative left over. So negative 1, right? Notice how I said the 3's cancel, but the negative sign stands for something, you know. When you divide a number by itself, it's 1, and then the negative 1. Okay? So now we multiply by negative 1. So negative 1 times 3x is negative 3x. And then negative 1 times negative 2 becomes positive 2. And you're subtracting, right? So we'll keep the standard notation there. And then we have negative 3 minus negative 3, which it's really saying negative 3x plus 3x, which is 0, and then 4 minus 2. 4 minus 2 is just a 2. And this right here is our remainder. Okay? So in other words, let's write out our solution. Six x to the third power minus x squared minus 5x plus 4 all divided by 3x minus 2 is equal to 2x squared plus x minus 1 plus the remainder over the divisor. Okay? So hopefully this makes sense. You can rearrange this last expression in different ways. And I encourage you to try to rewrite this so that this right here is not as a fraction, explore. Try to do things with this so that you can get it to look like something else. Okay, so there's a thing called the division algorithm. And so let's say that you have a function f of x and d of x. Okay, they're polynomials with d of x not equal to 0, and the degree of d of x is less than or equal to the degree of f of x. So f of x is larger in degree. Okay, so there exists a unique polynomial q of x and r of x such that you can write this in this form, right? So this is the dividend, and the dividend can be expressed as a product of the divisor and the quotient plus some remainder. Okay, so if you haven't done it, maybe we can rewrite the previous thing like such. Let's say we have the previous result, right? And you can kind of see something here. So before I told you, right, this is what we were dividing. Here was the quotient, which is this guy right here. And then here's my remainder. And then here's my divisor. What happens if I multiply everything so that I have the dividend by itself, which is what's up here? I'm going to multiply the divisor over to the other side, right? So hopefully you remember that when you multiply something to the other side or multiply to both sides of the equal, you're multiplying it to everything. Okay, so 2x squared plus x minus 1 times 3x minus 2 plus 2 over 3x minus 2 times 3x minus 2. So you notice that I didn't write it here on the left because it cancels, and then this cancels, right? And that kind of goes away, so we'll write it just without it. Okay, so again, dividend, quotient, divisor, and remainder. Okay, so very neat. This is nothing new. This is just a different form of organizing your product, and I think this is a great way to organize things. And if you're able to see it, it gives you more power to manipulate what expressions look like. You know, you can go from this expression above, where you have the remainder divided by the divisor, or just here, right, looking like the division algorithm. Okay, I guess one last thing to mention is that if the remainder is 0, right, you would think, or you have to say that the quotient and the divisor would be factors of the dividend. To put it into perspective, you have numbers, right? I'll say, like our previous example, we used the number 42. How about we use the number 43 divided by 7, right? What is 43 divided by 7? Some decimal, but I don't want a decimal, okay? I know it's going to be 6 plus 1 over 43, right? Well, I know that 43, if I multiply this 7 over, is the same thing as 7 times 6. Uh-oh, not 43, but 7, sorry. Plus 1. And it's true, right? 7 times 6 is 42, plus 1 is 43. So, dividend, quotient, divisor, and remainder. And you can reorganize it in that way, and it's super neat how it applies to numbers, and the idea is the same with polynomials, okay? The next thing that we want to talk about is synthetic division. What is synthetic division? What is the benefit, and why is there two different types of divisions? Now, we want to use synthetic division when the divisor is in the form of x minus c in some linear form, right? So if we compare the two methods, if we're dividing this polynomial by x minus 3, we would have it in this form, and the synthetic division form would be this. So let me quickly fill in the values for the long division. So a couple things to see here is that we already know how to do long division, and it takes some work. The divisor here is x minus 3, so in the form of x minus c, where c is equals to 3. So hopefully you're seeing some of the parallels here of the synthetic division. So we want to start seeing some parallels. Long division and synthetic division are essentially the same thing. Okay, they give you the same outputs in essence. You just kind of do them differently. Okay, so let's talk about the benefits. Obviously, the benefits is that this looks more slick, more clean. This is just brute force process, right? You multiply, you divide, you subtract, multiply, subtract, and you just go through the process. Now, how does synthetic division work? So, synthetic division, here's the highlights of it. From the previous screen, this is what we had for synthetic division. Where does the 3 come from? It comes from the divisor. X minus 3 was the divisor in the long division, and so you use the value of 3, okay, which is the value C. So you put 3. Now, where do the top numbers come from? Those are important. The top numbers come from the dividend, right? X to the third power, 4x squared minus 5x plus 5. These numbers here are the coefficients, the numbers in front of every term. What number is in front of x to the third power? There is a 1. What number is in front of 4x squared? Well, the coefficient is 4. What number is in front of negative 5x or minus 5x? Well, that negative belongs to that number, so you got to bring it down as a negative number. And then positive 5 is just a 5 without the plus symbol, right? So let's be clear about those things. We'll talk about these middle numbers in just 1 second. But the solution, this is supposedly the solution, right? So the first numbers, leaving out the last one, those are the coefficients to the quotient. So this is the one that goes here. That 7 goes here, and this 16 is right there. Now, here's something to understand. You started out with a power 3 polynomial. You're dividing it by a power 1 polynomial. Your solution is going to be 1 less than what you started with. So if you started with a power 3 polynomial, your solution is going to be power 2. So 1 less, regardless of what you start with. And then the last number here is the remainder. So let's go back up so that we can see it. Here's the remainder. Here is the quotient, the 1, the 7, and the 16. The 1, the 7, and the 16, and then here's the 53. Okay, so let's do it. Synthetic division, how does it work? So here's essentially what you're looking at, right? Long division wise, this is what you have. This goes into this. How many times? Except here it's a little different, right? So how does it start? Well, the value of C, then the coefficients in descending order. So what you want to do is make a line. Okay? And the first thing that you want to do, let me copy this so that I can keep on bringing it down. What you're going to do is bring down the 1. So you bring down this 1. First step. That's literally the first step. Then, once you have the 1 there, oops, what do you do? Well, here's what you do. You do 3 times 1, and then you put it right there. So 3 times 1 is 3, right? So we have a 1 here, we have a 3 here, and the next thing that you do is that you add. So 3 plus 4 is 7. So hopefully you're getting the hang of it. That's the first cycle. Then we say 3 times 7. I guess, let me. Three times 7 is 21, and then we add, right? And that gives us 16, and I'm going to continue using this one so I don't have to keep copying and pasting. And obviously 3 times 16 is 48, and then we add, right, and we get 53. So if you want to rewrite this as your final solution, remember that this is one less degree than what your dividend is. So this will be 1 x squared plus 7x plus 16 plus 53 divided by x minus 3. Okay? Now, let's talk about the remainder theorem. So let's kind of get into it. So consider the division algorithm that we talked about. And so f of x is your dividend and is being divided by x minus c. Right? I mean, it's you're dividing by some polynomial. Okay? And it looks like this. X minus c times the quotient plus some remainder that is a constant when you divide by x minus c. Similar setup that we had before, right? F of x is equals to d of x times q of x plus r of x. Now we're saying in this scenario is that we're dividing by x minus c, and when that happens, the remainder is just a number. It's a constant. So let's do some exploring and evaluate what we have up there in the purple, the function f at the value c. So what happens if you plug in c into it? Well, instead of x, you put in a c, and you have the following, right? Well, what is c minus c? It's a 0, right? So 0 times the quotient evaluated at c plus r. And so we get this interesting result. So is saying that whenever you evaluate the function f at the divisor value, right, what we used in synthetic division, you get the remainder. So that's kind of neat, right? That's what the last equation means. So this result is called the remainder theorem. Okay, so here's a more formal definition. Now, if the polynomial f of x is divided by x minus c, then the remainder is the function f evaluated at the value c. That's all that the remainder theorem says, is that if you divide by x minus c, you're going to get the same remainder as if you just plug in the number into the function f. Okay? Now, let's introduce another theorem, which is called the Factor Theorem. Okay? So looking back at the division algorithm, when we're dividing by x minus c, like we have here in the purple again. Now, by the remainder theorem, the remainder r was equals to f of c, right? We kind of showed that. So if that, that is true, so we have f of x be equals to this. Remember that r was equals to f of c. Well, let's look at the case when the function evaluated at the c value is equals to 0, then it goes away in the next step, and we have this, meaning a remainder of 0, meaning that it was evenly divided by that factor. What that means is that for f of x, whenever the remainder is equals to 0, whenever you plug in that value of c, what you're looking at is a factor of f of x. X minus c is a factor of f of x. And that's very powerful, because then you are able to factor or rewrite that function f of x. So it's a very, very interesting result and a very neat tool, and you have to understand this whenever you're trying to manipulate or solve polynomials. Try to find their roots. Okay, here is the definition for the factor theorem, the more formal definition. Let f of x be a polynomial. Okay, so case A is that if f of c is equals to 0, then x minus c is a factor of f of x. Okay, and then case B is that if x minus c is a factor of f of x, then f at c is equals to 0, right? It's kind of like a two-way street. Both statements are true in either direction. Okay, and that is everything for this video. Thank you for watching.